Hi, everyone. I'm Leavitt here at Teiko Bio, and I'm excited to show you this new feature. Determining baseline is very important to analyzing patient samples across multiple time points. And often, modern drug treatments often mean complex dosing schedules, sometimes in combination with other drugs or different types of treatments. A modern and popular therapy called chimeric antigen T receptor therapy, also known as CAR T therapy, engineers T cells to express a chimeric antigen receptor. This better helps T cells target cancer cells. The way this therapy works is a patient's own T cells are removed, engineered to express this receptor, and then prior to reintroduction of these engineered T cells, the patient's immune system is depleted using chemotherapy. This is also known as lymphodepletion. Now, when the engineered T cells are reintroduced, they are better able to expand and persist in the patient. This overall improves the patient's combat against cancer. Being able to better normalize the data to these lymphodepletion time points increases the signal and reduces the variance of the data. Now you can better identify biological changes that have occurred since the introduction of this therapy. This is one example, but the theme of modern drug development is complex dosing, combination therapies, and biological engineering. We recognize the complexity of this field and have designed our web app to now allow the ability to normalize to any time point in the entire data set. Not only this, we pre-calculate statistics for all combinations of comparisons. No samples left behind and no cell populations left behind. And of course, our statistics are multiple test corrected, helping to prevent false discoveries. All right, so let's dive in and show you this new feature. Feel free to navigate over to app.teiko.bio, log in with our demo account, and try it out for yourself. You'll have access to the same data set that I'm going to show you today. So first, what I want to show is to first see what this is all about. We want to visualize the data normalized to any time point. In this data set, we are testing the stability of PBMC samples that have been fixed and then stored in a 4-degree refrigerator for 0, 24, 48, and 72 hours. That is in comparison to samples that are stored at a negative 80-degree environment. So the first thing that we're going to do is we're going to navigate here to immune changes over time. Then we can start by looking at these functional subset frequencies across all of our markers. To best see this effect, we like to click this toggle, connect time points by subject. And then we apply a group by filter where we color these lines based off of the subject, or in this case, the sample. Now, when I use this drop down, we can really see this effect in action. So first off, there's no normalization applied to this data set. Now, when we click H0, we normalize the entire data set to that first time point. And here, when we do that, the effect becomes very clear. There's a reduction in these cell types. Toggling back and forth, we can see how much clearer the data is when we normalize to that first time point. But of course, we give you the ability to normalize to any time point. So here's H24, 48, 72. You have the ability to observe this data normalized to any of these time points. Now we can start to ask questions and use the statistics that we have already automatically calculated to guide our understanding of this data. For example, are there any significant changes between hour 24 and hour 72? When we look at the data unnormalized and apply a significance filter of 0.1, we see no significant effects. But once we normalize the data to the H0 time point, these significant effects emerge, and we see a decrease across all of these cell types. This is what we would expect when keeping the samples at 4 degrees versus negative 80. But now let's think about normalizing to another time point. It's hard to justify normalizing to another baseline for this analysis, but let's assume that lymphodepletion occurs on H24. This now creates a biologically relevant baseline that we would want to normalize to. So let's compare H48 to H72. These would be the time points following lymphodepletion. Applying a stringent significance filter of 0.1, we see no results that are significant. Even if we normalize to the H0 time point, we still see no significant effects. But now when we normalize to this lymphodepletion time point, we see the significant effects all of a sudden emerge, and there's many of them. And the reason why we see this is because we've reduced the variance in the data set to biologically relevant time point. Please reach out if you have an interesting drug trial where you need the ability to normalize to any different time points, whether it's lymphodepletion or the introduction of a new therapy. We do the work so you can find the results faster. All right, thank you for coming. I hope to talk to you all soon. Bye-bye.